I hope that e-learning has been treating you well. I hope that you're doing okay. And I just want to start a new video today for the review homework packet for chapter 12, which is the data unit. Now I'm going to try to run through this a little bit quickly because it's a longer packet and I would love to try to get this done in one video. So please feel free to scroll ahead to the part that you need. Fast forward, rewind, do what you need to, and don't hesitate to send your teacher an email if you're struggling and you would like a little bit extra support. I'm going to start this video with the section that talks about correlation and causation. And I think it's important that you know what that word means before we start. So it says here, read each scenario and answer the questions. And the first scenario says the number of hours playing video games and the number of hours that you sleep at night. And what it's asking for here is correlation in this box and causation in this box over here. Correlation means that you have a link between the two variables, some sort of connection. Is there a reasonable connection between playing more hours of video games and then probably having less hours of sleep? Or I don't know, maybe more hours of sleep. So as you think about more hours of video games, would it seem logical to have more hours of sleep or less hours of sleep? If you say more, it would be a positive connection. If you say less hours of sleep, it would be a negative connection. If you have no idea, you would say none. Now, causation means that playing video games causes, with no other variable, you to sleep less at night. If you can think of any reason for you to sleep less at night than video games, then you would say no for causation. Cause and effect relationships work that way. If you do this one thing, then for certain this other thing will happen. And I have a feeling this one's gonna be no. Now, as I'm thinking logically, just what do I understand about playing video games? Well, if I play a video game a lot longer, there probably is a chance I would sleep a little bit less at night. So I'm gonna go with negative correlation because I'm getting less sleep. Now, does playing a video game make you sleep less? Well, no. There are plenty of other reasons why you might sleep less at night. Can you think of one reason other than playing video games that would cause you to sleep less at night? Well, maybe you have, I don't know, what is it called when you just can never fall asleep? I can't think of the word. I would say maybe something genetic. Some reason why you cannot sleep. Your brain just won't stop. Perhaps we're worried, especially about the coronavirus going on right now. So maybe there is another reason why you can't sleep at night. So I'm going to say no for causation. I'm going to have to think about that word. Why can't I think of that word when you just can never fall asleep? Anyway, okay, number 2. The number of times that you are tardy to class and the number of detentions you receive. Now, when I was living in Minnesota, it was incredibly common for 3 tardies to be the reason why you get a detention. Now, I'm not exactly certain how every school in the entire states do this, but if you are tardy more to class, generally the rule is that you do get a detention the more tardies you receive. So more tardies, more detentions, that's a positive connection. Now, does a tardy cause you to have a detention? In most cases, yes. It's logical to say that when we do our hall sweep pass, that after you have more tardies, you actually do have to serve a detention. And if I remember right, it's 3 tardies and you get a detention. So the more tardies you have, it's likely the more detentions you'll have to serve. Letter C, the amount of calories that you burn and the amount of weight that you lose. Is there a connection with burning calories and losing weight? Well, yeah, the more calories you burn, the more weight you're going to lose. So that's going to be a positive connection. Is there a causation relationship? Can you think of another reason why you would lose some weight other than burning calories? Well, this is a pretty strong connection. So I would be swayed for either of these answers depending on what your explanation would be. So if you say yes, I need to see an explanation that really just logically explains that if you burn, 1,000 calories a day, maybe you're on that stair stepper machine, you know, for an hour, then you're probably going to lose more weight than if you weren't on that stair stepper machine. But if you give a different explanation that could explain why this would not be causation, like something genetic, or maybe you're on medicine, or something else is going on, I would be likely to be swayed to the answer no based on the explanation that you provide. So think about that. The last question here: the higher the salary that you make, and the more likely that you will vote in a national election. Does having money lead to you being more likely or less likely to vote? I said no way. I said whether you make money or not should not have any impact on whether or not you vote. I said no correlation. Now then, for me, it's easiest to answer no here, because if there's not even a connection, how could there be causation? That wouldn't make sense. To me, in my understanding of how the world works, salary does not influence whether you vote. Influence whether you vote. Okay, I'm going to turn to the next page now. Number 2, the following graph over here on the right shows a relationship between the grade in the math class and the average salary. Grade in the math class is on the x-axis, so that's our independent variable, and the average salary, which would be on the y-axis, is our dependent variable. And it looks as if, as you're getting a little bit higher of a grade in math, you could tend to make more money, but there are other people who scored pretty high in math and didn't make as high of a salary. This correlation looks like it's generally trending in a positive manner. For question B here, which statement about this data would most likely be true? Is there a connection? Maybe slightly. Is it causation? I would say there probably is a connection between the two, but definitely not causation. I do not think a better salary will lead to a higher grade. That's even opposite of what we said. We were investigating, does math class influence salary? So this is even in the wrong order. And there tends to be a general flow to the data, so I wouldn't say no correlation at all. It looks like there might be a small connection. If possible, draw a line of best fit. So look at a couple points, and if you could roughly estimate, if you were to put a line through the data, would roughly half of your points be above and below? You can go ahead and count it out yourself. Look for a line that will flow through the pattern of the data in the same direction as the data, and roughly half the points above the line as below the line. Explain why that line is a good fit. Well, those are those two reasons. Number 1, your line should flow in the general direction of the data. And number 2, roughly half of the points should be above the line, and half of the points should be below the line. I call this a centered line. At the bottom here, we're going to shift gears and talk about whether something has a bias or not. In this scenario, if it is a biased scenario, write it in a way that it could be unbiased. For question A, it says the manager of an apartment building asks only the first floor residents if the noise level is a problem. Well, if he's only asking the first floor residents, I would say there is a level of bias there. If you're living on the first floor and there's a noisy tenant above you constantly stomping on the ground or playing loud music, you're gonna feel like it's super loud and noisy. But if you go to the top floor where the tenant is not really able to hear the people below them, then maybe there's going to be a slightly different answer here. So instead of only asking the first floor, he should ask someone from all the floors. Number 2, 2 students out of every SRT is asked what their favorite vacation destination would be. That to me sounds pretty unbiased. For extra credit here, can you tell me what sampling that technique would be if you asked 2 students out of each SRT? I'll give you a second to think. It's called stratified. All the SRTs are already kind of your population grouped, and then if you ask a little bit of people, a small group of people from each of those groups, that's called stratified. Letter C, every 5th student is surveyed to determine what their favorite after-school activity is. I would say this is also unbiased. And for a little extra credit, can you name that sampling technique, every 5th? It's systematic. Both of these are very good ways of collecting data. Letter D, a nurse uses basketball players to find the average height of students attending high school. Basketball players. Do you think there might be some sort of bias here? I definitely think there might be some bias there. Generally speaking, in my understanding of how sports work, most basketball players tend to be a little bit taller than the average student. I'm not saying there are not short basketball players, but just kind of the general trend. So instead of the nurse asking only basketball players, I think it would have been better if she asked, 2 students from every SRT. What their heights were, and then she could track better that way. Number 4, the question you are investigating is, what is your favorite brand of sneakers, and which group of people could be used to obtain an unbiased sample for this question? As I'm looking at these options, if I want to know favorite brand of sneakers, I should not be reaching out to people at the Nike store. That really wouldn't be the best way. And maybe a sneaker factory, maybe that factory is specific to a brand, like the Nike factory or Adidas factory. And so instead of going to the factory, I would ask people attending the game, probably all of them wear sneakers to some degree, and then you could ask, hey, what's your favorite kind of sneaker? Now at the top of the next page, question 5, it says, use the following scenario to answer these questions. Animals at the zoo are divided into continents. Then 2 animals were selected at random from each group to have their blood tested. Identify the sample and then suggest a population from which it was selected. If it's 2 animals per continent, that would be a stratified. And the sample is 2 animals from each continent. The population from this sample would be all the animals at the zoo. Generally, how I understand sample and population to work, sample would be a specific number, and population would be the word all instead of a number. So if you're looking at animals from that zoo, from the continents, it would be all animals from that zoo. Letter B, classify the sample as simple, random, systematic, stratified. I had already said stratified here. Number 6, determine whether each sampling method is random, systematic, or stratified. Every 5th is a system. Drawing random ID numbers out of a hat would just be random. Now the pictures for number 7, this looks like it's going generally in a downward, so negative pattern. The second picture looks as if it's moving upward, which would be positive. Think slope. This is going down, so correlation and slope have the same sign, positive or negative. And this one, it's very hard for me to determine, so I said none. Number 8. Use the graph at the right to answer the following questions. Choose a couple points on the graph so that the line through them closely represents the pattern. If you look at the 2 points that they give here, -3, 4, and 1, 0, if we were to put a line through this, I think it goes down too fast. The points are kind of more going in this direction, and that goes down too fast. So I said this was not a good option. Letter B, -5, 4, and 3, 0. If I put a line through these 2 points, does it flow better for the pattern? I think that's actually pretty good. Let's count. 1, 2, 3, 4 points below, 1, 2, 3, 4 points above. I'm gonna go ahead and stop there and say B looks pretty good. I drew the line over here on the graph, and now I'm gonna calculate the line of best fit. So with the 2 points that I have, I'm gonna start with slope, then I'm gonna use the point slope formula and then convert it into slope intercept formula. My 2 points, if I plug in, my slope is going to be 0 minus 4, my second y minus my first y, and then for the denominator of my fraction, my second x of 3 minus my first x of negative 5. This is going to be negative 4 over 8, which is a slope of negative 1/2. Now in the equation of point slope, pick one of those 2 points. I'm going to go ahead and pick the point 3, 0. So for this equation, I'm going to use y minus the y value of 0 equals my slope, negative 1/2, and then in parentheses, x minus my x value of 3. If I distribute my slope, I have negative x times negative 1/2 times x, and negative 1/2 times negative 3 would be positive 3/2. Think of this as the fraction 3 over 1, and when you multiply fractions, you multiply top times the top, bottom times the bottom. Now y minus 0, that makes this pretty simple because this is actually already in slope-intercept form. Y minus nothing is y. So here's the equation in slope-intercept form. Now the next page. I already started this off ahead of time by taking and adding some columns together. So if I had girls and boys in different grade levels at Carmel High School, I took 254 minus 98 to get 156. I added these two together to get 422. I took 390 minus 215 to get my 175, and I added these two together to get 652. If I add these 4 numbers, you should get the total 1718. And then what I did is I added those 4 together to get 871, and then I took 1718 minus this to get that total, but you could have added those as well. Now that your box is filled out with your information in the table, now you can go ahead and answer the questions. Look for any set of questions that give you 2 pieces of information, and then think about how that's going to alter your subgroup versus questions that ask you only 1 piece of information, like just boys, or versus 2 pieces, girls who are seniors. If you're given 1 piece of information, the denominator is going to be your grand total. If you're given 2 pieces of information, the total for the bottom of your fraction is going to be based off of that first category. So this one here, calculate the percent of seniors. I just need to know the total of seniors out of all my students. So 652 divided by 1718. If you use your calculator, you're going to get 38%. Out of the freshmen, so out of the 9th graders, so out of those 254 students, oops, I wrote that wrong. How many of them are boys? 156. I used my calculator and I got 0.61. Out of the girls, so the total for girls, how many of them are seniors? 342 out of 847. Use your calculator to divide. You should get 0.4. How many boys do you have? Well, this is only 1 category, so I'm going to use the denominator over here, which is the grand total of all the students that were surveyed. How many of them are boys? 871. If you divide on your calculator, you're going to get 0.51. How many of the sophomores are girls? Sophomores are 10th graders. Out of 422 sophomores, how many of them are girls? 232. This should be 0.55 on the calculator when you divide. Girls who are freshmen, out of the girls, there were 847 girls. How many were freshmen? 9th grade is freshmen, there's 98. 98 out of 847 is 0.12. How many students were sophomores? So total number of sophomores is 422 out of the total number of students surveyed, which is 25%. How many of the seniors are boys? Out of the 652 seniors, how many of them were boys? 310. If you divide, you're going to get 0.48. How many girls were surveyed? Girls 847 out of 1,718. If we divide how many girls we had surveyed total, 0.49. How many juniors were surveyed? Juniors are 11th graders, so 390 out of all the students. This, if you divide on the calculator, is going to be 23%. Boys, out of the boys who are juniors, the total number for boys is 871, and the number of juniors, 11th graders, is 215. If you divide on your calculator, you should get 0.25, 25%. Now, how many students were freshmen? Freshmen is 9th graders, 254 out of all of the students, which was 1718. If you divide your fraction here, you should get 15%. And then junior girls. Now, they put this together. How many junior girls did we have? Juniors that were girls is 175. There was not really who are also something else, so that's going to be out of 1718. So together at the same time, junior girls, 175 out of the 1718 total students there were. This is 10%. Great job sticking with me so far. We're almost done. For the last sheet, what I'm going to do, I actually already started with these points on the grid, just kind of to save a little bit of time. And what I'm going to do is talk about, with the points that I have provided on that line, talk about what 2 points I'm going to pick for my line of best fit, and then why, and then I'm going to calculate the line of best fit. So as I looked at these two pieces of data, it says sampling of students comparing the length of their hand span versus their forearm. Hand span was on the x-axis, forearm was on the y, so as I graphed my points, I graphed it x comma y. The 2 points that I selected to put my line through were these 2 points. A point near the beginning of the set of data and a point near the end, so that when I connect them, it flows through the general pattern of the data, and half of the points roughly left over are above the line as below the line. Now if you see I made a mistake here, so don't count that point as a point, that's a mistake, but 1, 2, 3, 4 points above and 3 points below, that's probably as good as I'm going to get it. If I had an odd set of data like 9 points, I can't split it perfectly. The 2 points that I listed here for my data set was 16, 20. And this point over here, 23 and a half, 28. Now what I'm going to do is find the slope through those 2 points. y2, 28, minus y1 of 20, over x2, 23.5, minus 16. Use your calculator. You're going to get 23.5 minus 16, 7.5 for the denominator. When I divide, I'm going to use the decimal for this. 8 divided by 7.5, I'm going to use 1.07. Just to be a little bit more accurate, I'm not going to round to 1.1. So 1.07. So that's my M. Pick either of these 2 points, it doesn't matter which one, and we're going to plug them into point slope formula. Y minus y1 equal to M, your slope, x minus x1. So this is going to be y minus 20 is equal to 1.07 and x minus 16. Distribute your slope to your x and to your negative 16. You're going to have y minus 20 is equal to 1.07 times x. Now this 1.07 times negative 16 is negative 17.12. And now to solve for y, I'm going to add 20 to this side. So plus 20 on my calculator. My y-intercept is going to be 2.88. So y is equal to 1.07x plus 2.88. So there's the equation of my line. Use your equation that you have to predict a hand length of 17. Hand length is x. So I'm going to place 17 into the x of my equation. When I plug in 17, I get a prediction of 21.07. And that's centimeters for the forearm. All right, we are cruising. We have just a little bit left on that review packet. This is the vocab that we had for the unit. Sample, correlation, random sample, frequency might feel new to you, bias, statistics, inference, correlation, coefficient, the R value versus just correlation in general, bivariate data. We did bivariate data in, let's see here, this table here. And then causation. For number 1, a blank is a part of the population that is surveyed. This is going to be sample. A part of the population is sample. Number 2, blank are facts or data of numerical kind, assembled, classified, and tabulated so as to present significant information about a subject. This is going to be statistics. Statistics are pieces of information. It's data collected. We classify it, we tabulate it, and it's supposed to give us information. Blank is a degree of relative correspondence between two sets of data. This is going to be your correlation. Correlation is how your two pieces of data connect. Blank is the number of times the value appears in the data set. This would be frequency. Frequency is just a fancy word for count. Count the number of times that this appears in your data. That's what frequency is. If you've ever seen a histogram, how tall your bar is a frequency. It's the count of how many things fit that category. Number 5, a sampling error that cause one option to seem better than the other is called bias. Number 6, blank is when a change in one quantity causes a change in the other. So a change in one quantity, a change in the other, this is bivariate. So a change in one number causes a change in the other. That is going to be, oh no, I'm so sorry. I was looking at my key on the wrong one. This is bivariate. I apologize for that mistake. Bivariate data. Okay, 2 sets of variables. I'm sorry. Let's leave that blank here and let's come back to that. Number 8, blank is to conclude or decide. Make a conclusion, make a decision. This would be to infer. An inference is a conclusion. Number 9, a blank is in which every individual or element in the population has equal chance. That's going to be random. Okay, now I'm going to go back to this one that I skipped. I'm so sorry for skipping that. When one quantity changes the other, this is causation. Think of relationships where if you change one thing, it's going to change the other. I think the easiest example that comes to my mind would be the more miles you drive your car, the more gas you have to use, because our cars use gasoline. So if you're going to drive more, you're going to cause yourself to need to buy additional gas. And so that's going to be a causation relationship. Sorry about that. I'm so sorry I messed those 2 up right there. And then number 10, the very last one, almost done. Blank is a numerical value that reflects the relationship between the 2 variables. So not just that they have a relationship, but what it is called as a number. That's your R value, which is your correlation number, which is called the correlation coefficient. Whew, great job today. Hope you're studying well for your data test, and I hope the best for you. Good luck.